Okay, so let me start today's webinar, and this webinar is based on the signal processing from the Android Android device, mobile phone or tablet. So as you know that we can get raw data from Android device nowadays, the GPS raw data, but the raw data that we get is a little bit different from device to device. And also some device, they have a multi-frequency, some device, they have only single frequency. So the purpose of today's webinar is to let you know what type of raw data we can get from Android devices, and also how we can process, what are the applications or softwares available to log those data, and also the software or the tools to process those data. So these are the things we'll discuss. So basically how to log the data and how to process the data. So as you know that just the mid of this year in June, so we had multiple frequency capable Android device, and I have logged some data, and I will show you this data. Main presentation is based on not my handouts or not my slides, but this is the slides from Dr. Frank from Google. And I got his permission to use these slides and also to distribute to you so that you can check the details. And it has about 65 slides. So, but I will not go through all these slides to explain the things because it takes a lot of time. Maybe we need about 4 hours to do that. So today we have about 1 hour, maybe around 70 or 80 minutes. So I will go very briefly about these things and just tell you how to log the data and how to process the data and show you some results or some data actually how I did or how you can do later. And you can get these slides or documents so you can download and check after the webinar. So please check it and download the software in your Android, in your computer. If you have a device, Android device that is capable to output raw data, so you can log some data and process yourself. And before we go to the actual topic, I just want to give you some background information which you need. So just let me give you the very basic signal structure for GPS. Probably you know it, but if somebody is not aware of this, I just repeat. So we have a carrier signal, which we call L1, L1, L2, L5. So these L1, L2, L5 means we have different frequencies. And then we have PIN code. It's also called the CA code. So this is the CA code. And also we have the navigation data. Okay. So these navigation data, they include all the satellite ephemeris and clock data. So these are the three things required to make a GPS signal. And they are combined and transmitted from the satellite so that you get the signals here. Okay. So this is a very brief description of the GPS signal structure. And when we talk about the raw data, so what do we mean by raw data? So we need to understand about the GPS signal structure first. So if you look at this, so this is the overall architecture of the GPS receiver or any GNSS receiver in a very general way. For example, you have antenna to get the RF signal. And after the antenna, then it has like an amp or to a down converter, means the signal is coming at 1.5 gigahertz, and you have to convert to very low frequency just after the antenna. So it will convert, say, something like a 16 megahertz or 24 megahertz. So this is all analog up to here. And then it has to be converted to digital. It is done by AD converter, analog to digital. And during this process, so depending upon the signal strength coming to the receiver, the AGC will be working on this to increase the gain of the amplifier or reduce the gain if the signal is too strong. So AGC is working, and also it will convert. Then we'll have the digital signal output here, and then your receiver starts working to process this signal in the receiver or in the computer. And this we call the baseband signal processing, okay? So what we mean by baseband is to actually find out the signal. So we have different steps like acquisition, tracking, and navigation. So acquisition means we just try to find out which satellites are visible by approximately calculating the Doppler and the chord phase. So during this acquisition process, then you need to know the PI and codes to check the incoming signals in your receiver. So the very first step is to find out the visible satellites, because, for example, GPS has 32 satellites, and out of these 32, any other few satellites, maybe 10 to 12, or depend where you are. So 4 to 6 or up to 12, we can see. So you can see any 12 of those 32 satellites, depending upon where you are and whether you are in an open area or not. And once you know the approximate Doppler and chord phase and the visible satellites, then you continuously start tracking those satellites. So we say tracking, and this means actually we are now demodulating your carrier and the PI code to get all the navigation data. So you are demodulating the signal, like in the radio, amplitude, AM, FM radio, we demodulate the signal so that you can hear the actual voice. So this is what we do in the GPS receiver. So you get all the necessary data from the receiver, and there are different terminologies called DLL, delay lock loop, or frequency lock loop, or phase lock loop. And once we do all this processing, what you get is the navigation data. Means this data, now you have all the necessary things to compute the position output, position, velocity, or time. So they basically include the ephemeris data. This will tell you the satellite orbit, where are the satellites, and also the clock data of the satellites. What is the time in the satellite it's broadcasting, and how much is the satellite clock error. So these are all necessary data to GPS signal. And when we say raw data, so this is what we mean by raw data. Okay, normally your receiver gives you the position output, position, velocity, and time. This is what you get in the RINEX. Carrier phase and the Doppler, SNR, and these are also called the raw data. But PBT data, we don't call it the raw data. We just say the position output, or PBT data, latitude, longitude, height, and the time. So these are the 4 things. And apart from that, we have other data called the pseudo rates, carrier phase, and all. But these raw data are output only by some specific receivers. Normally, those receivers which are used for survey, because you need to do some error, like RTK or PPP or other differential corrections and so on. So you need the raw data to do those process. But the raw data that we are going to talk today is not even pseudo range. So it's even before the pseudo range. Now the mobile phones, they output many intermediate level of raw data. That means all these processing are taking place. So the tracking outputs, all the outputs, not all, but many of these outputs from here are between tracking to navigation level. So we get lots of output, and we can see this data, and we can log this data. See how this raw data looks like and what we get in the later examples. So this is what we mean by raw data. It's not the position data. pseudo range, or even before the pseudo range. So all these intermediate data are output from here. Okay, so these are acquisition results. So I will just skip. So it's not related to. For example, so this is just some background information for you that when we do the signal tracking means we demodulate the signal. Once we demodulate the signal, we have signal. So these blue are the signals. These reds are the noise. So we get this stream of the output continuously from the receiver after the baseband signal processing, after the tracking. So if you look at this, you can see a very clear pattern of ones and zeros. We don't say ones and zeros, we say the +1 or -1, okay? Either positive or negative. Only two values are possible because the GPS signal is it's a binary phase shift keying, BPSK. So you have heard this many times. That means plus or minus, okay? That's the meaning binary phase shift keying. And you can see the signal output very clearly. You see either plus or minus. You don't get the intermediate values. And all these little bit, these zigzags are due to the noise. So you can see how much noise is actually there looking at these blue dots and red dots, okay? And you compute the power from blue dots, you see the noise here, the signal power, and this is the noise power. So you divide this, so you get SNR, signal by noise. You see the noise, the signal, oh, sorry, the signal, the blue, and the red is the noise, okay? And this one, again, you plot in a different way. So you get these two types of scatter. That's a BPSK. Okay? So now we go to, so these are the background information. So we go to the tutorial today from Google. So let me share another file. Which one is this? Okay, this one. So this is the actual file for today's lecture. So I gave you just some background. And if you look at this, so it's called the raw measurement, and it was done by Dr. Frank during the ION in Miami in September. So I got these files from him, and so I will just use this file to give you some talk today. Okay. And I will give you this file so you can download later, and you can download all the informations from here, okay? So you can download this from here. And also there are some the slides you can download from here, and also many other sample data, okay? You can see the link here. So these are the list to the resource files. You can get it for your further study. So my purpose today is not to make you learn everything about how to process the data and how to do everything. This is not possible in 1 hour. But today's objective is just to let you know that Android device can output the raw data, and how to log the data and how to process the data, and where are the resources that you need to learn. And after this tutorial, if you are interested yourself to do so, please do it. And if you are not clear or don't understand, maybe we will do one more webinar, maybe after 1 month or 2 months later. Okay, so the purpose is just the introductory type today. And these are the informations available here, so you can download. And so we'll talk about the actual raw data measurements. And before that, so this is one information about how Google API. This is the Google API. You see Android, Google Mobile Service, Google Mobile Service, and the Android Location Engine or Android Location Service. So in the Android, we have two APIs, one from Google, one from Android itself. But the one from Google, so you have to use the Google API. Means some countries, like in China, you cannot use it. In China, you are not allowed to use Google. Okay. So, but other countries or any other countries, so this is okay, including China, and there's no restrictions on using the Android location engine. So probably we'll base all our developments based on Android location data. But currently, so we have all necessary APIs from Android location, this API engine. But in the past, when I mean before Android version 7 until version 6, we can get raw data only by using the Google mobile service. Okay? And now this is available in Android location from Android OS 7. Okay. Now, if you have a mobile phone that is OS 7, so you can use Android location API to write your own program to read the data if you want. So you have to use OS 7 or higher, 7, 8, or now 9. And this location is already available in the past, but now they have added GNSS measurement and GNSS clock data. So these are the two things that were added. Okay, and these APIs will help you to log raw data, and you don't have to write a program yourself. You just download the app from the Android location, then you can log the data. Yes. And these are the list of the mobile phones that are compatible with the raw data. Not all the Android data, they can output raw data. Only some of them they can output. This list is a little bit old, so you can check Android, and you can see the new list. They have many new mobile phones which are capable of output raw data. And logging tools, so how to log the raw data in your Android device. So if you have an Android device, so what you have to do is, first you have to download the app called the GNSS Logger. And this is not available in the Google Play at the moment. So you have to go to the Android homepage to log this. And these references were given in the first page of this document. So you can go there. And when you go there, you can see the homepage, some link to download the GNSS Logger app. And you install this app to log the raw data. Okay. And this doesn't work in real time. The processing has to be done in the post-processing mode in your computer at the moment. So you will use this app just to log the raw data from the GPS receiver inside your Android device. So in order to process the data, then you have to download this GNSS analysis software, and this software is based on MATLAB. Okay. So in your computer, you download this software, you install it, and it works even if you don't have MATLAB license, because they have compiled the tool, including the MATLAB libraries, and you don't need a separate license for that. So you can, it will help you to download everything, all necessary MATLAB run this software. So you download this, install in your computer, so that you can do the post-processing of the software. And I'll show. And this is the screenshot of the logging tool, okay, of the GNSS Logger. So once you install the app and you run the app, so you will get a window like this. Then you set up what you want to log. Maybe you want to log the location data itself. Also, you want to have a measurement. Measurements means the raw data, the raw measurements. And this navigation message means the navigation message bits, okay, the bit data. Do you know what I mean by bit data? For example, in the GPS L1CA, we have a navigation data. So this navigation data has a 5 frames. Each frame has 300 bits. And all these bits we can download, we can see, or we can log using this option. So you can log every bit of the data coming from the satellite itself. Okay, and that's very, very nice for many applications where you really need to look at those navigation data bits for like interference issues, not interference, but for example, some bit error analysis or some other things to find out the ephemeris data yourself from the navigation data and all. So this is very useful. And it has different windows, so to show you what it is logging and how it is logging. But since you get such a this type of text data, a lot of this is scrolling and all, you really don't know what's going on. So even if you look at it, you just get some figures, some values, and this will tell you something, but you really don't know what is this, because we don't get now pseudo range or carrier phase, like those type of values which you are normally looking at it. So the values here you get is even before it outputs a pseudo range. It's very intermediate outputs from the tracking loop. So these are the things you get. And you log all these into a file. And once you say stop, then you email or many other means. Okay, you can transfer this file to your computer. Then, and if you look at your Android device, so you will see this folder called GNSS_log, and all the files will be automatically logged here. So you don't have to worry, even if you can't send the email. Okay, you just say escape or cancel, the file will be still here. So you don't lose the file. Everything will be here. And you will see only one file for all the settings. I mean, for every log, you see only one file, and that file has all the measured data, including navigation data, NMA data is there. Now, the actual thing is, to compute the position data, so you have to calculate the pseudo range. Okay? You need a pseudo range, you need carrier phase, and so many other informations. And the raw data you get is not the pseudo range. It's even before the pseudo range. So this tutorial or this handout will tell you how to calculate the pseudo range from the raw data. So actually, this tool is very, very good if you want to learn how a GPS receiver works inside. Normally, it's like a black box for us because you just put the power on and you get the position data. But if you really want to know how it is working inside the receiver, you have to look at this type of raw data. So this will really help you to understand how to calculate the pseudo range from your signal, and also how to calculate the position data from the pseudo range. Okay. Just a minute. And these are some slides explaining about the pseudo range and all. So I don't go through these because we had covered these type of things in the past webinars and all. So I will just skip these slides. Okay, so, and the next one is about the API itself. Now, before I explain that, there are two different types of APIs. One is from the Google, okay, Google this mapping. Another is from the Android location. So you can use either of these or the combination of those, okay? But the only thing is that if you use the API from the Google, so you can't use it in China, okay? You have some limitations. But now, if you are using the OS 7 or higher, so you have everything here. All the necessary tools are available here. So I'm not sure what special things are available in the Google GMS. I need to check, but I think for our normal raw data measurement and processing, all the APIs available here. is enough. And this is required only if you are going to write the program yourself to do something different from what these softwares that you download is capable of. Okay. For example, if you just want to do the signal processing to learn how it works, how to calculate the pseudo rates, you don't have to write any API yourself, any program yourself. But if you want to make some new application, or some system integration, or some new system by using the raw data from your device and use this raw data to do something else, then you need then you have to use some of these APIs. Okay, so let me skip these files. Maybe we better go to the home page directly to show you what are these. So let me share another screen. I will stop this, and I need to share. Okay. So this is the home page. Okay. So you can see here, developer Android. Okay. So it says raw GNSS measurements, and here you see GNSS Logger APK. So this is the app you need to download to log the data in your mobile phone. Okay. So download this one after the webinar, so you can install in your Android device, and then you can use your device to log the raw data. And for the analysis tool for post-processing raw data, so if you are using Windows, so click here, okay, and you can download the software. For Windows, for Mac, it's here, and Linux is here. So I suppose that many of you are using Windows. So if you click here, okay, so I just clicked. So let's see. Okay, I'm getting here. What do you want to do? So then it will ask you to download, save the file. So you save this file. So when you do this, when you run this file, so it will just run the installer, and after you run it in your computer, then it will start downloading the MATLAB runtime library. And it will take you about, depending upon your internet speed and the computer, 20 minutes or half an hour, because the total size of the download is about 800 megabyte. Okay, so you really need to have a little bit big space in your computer, and also you need a little bit big memory, because it will download the full MATLAB runtime libraries, all necessary tools, libraries, everything to process this data. So the size is about 800 megabyte. So it will take about half an hour to install. So once you do this, so just follow the instructions you get on the screen, and everything should work well. And in case if you already have a MATLAB, you can use your existing MATLAB license, but you really need to set up all the parameters yourself, and sometimes that is a little bit difficult because of different version, the release and all, and they sometimes are not compatible. So the best thing is to download everything and install from here. This will work for sure. I have installed in my 2 computers, and I didn't find any problems. And then now we can see, so these are the things, pseudo rates, what it can output, navigation message and all, the clock data. And these are the list of some of the mobile phones, okay, that can be used to log your in the Android device. Okay. For example, the very new Pixel 3 from Google, so it can give you the accumulate delta range. This is the carrier phase, heart rate clock, but it doesn't support L5 signal, and it supports GPS, GLONASS, Galileo, and Beidou, but not QGSS. Okay. and it outputs all the raw data, but it doesn't output a navigation message. So if you need a navigation message, so you have to select maybe some other device. Now I use this one, Xiaomi, and this is the most powerful or most, how to say, the strongest in terms of the GPS receiver. You see, it can log L5. So this mobile phone has a dual band L1 and L5 receiver inside, and it can also receive the signal from GPS, GLONASS, Galileo, Beidou, and QGSS, all the satellites except the Indian RNSS. And it can output navigation data, it can output pseudo rates, carrier phase, everything except the AGC, auto gain control. But normally auto gain control, probably you don't need it unless you want to do something related with the interference and jamming analysis using your mobile phone data. Then the AGC value will really help you to look at those analyses. Okay, and there are also some very cheap, low-cost Android devices that can output raw data. For example, Huawei Mate 10, so it is still outputs, you see, the navigation data, everything, but it's only GPS and GLONASS. Okay. And if you go for Huawei Mate 10 Pro, this is more expensive. So what you get, just the QGSS, okay? So in terms of GPS, you don't get much except addition of QGSS satellite. So, but in terms of cost, maybe it's more than 2 times. So if you are looking for the low cost Android device to log the raw data, so maybe Huawei Mate 10 may be a good option. You have GPS and GLONASS. But if you want to have sites, I recommend okay, Huawei P10 Lite. Oh, I have a P10 Lite actually, but it's only GPS. Or Huawei P10. So you see P10 also everything except L5. Okay, but P10 is a bit expensive. So yes, anyway, so the whole list is here. Okay, but this is not everything. Some other devices may be capable of logging the data, so you have to check it. But anyway, if you plan to buy a device to log the raw data, and if you want to make sure that your device works, so please check this list. So this is one information about selecting the device, and I already gave you the GNSS Logger app. You see, so here you can download the Android app to install in your Android device. Okay. Also, if you are a programmer, the source code itself is available. Or if you just want to use, so download this app and install in your device. It will work to log the data. And this is a software that you need to install in your computer if you want to process for the post-processing of the raw data. Okay, so this is all about the tools and the software for your device and your computer. Now I will show you some, okay, what else is there? Okay, so this is how it looks like, logger analysis. And once you install this software, this one, in your computer, so it will look like this. Okay, you will get this window. Okay. So when you run that software, you will see this one, and here you see find log file. So from here, you input the file and analyze and plot. So you do the analysis and plot all. So this I will see actually by running the program. Okay, so let's example how it works. So I need to change my computer, just a minute. Okay, I'm using another computer now. to show you how it works. Where is it? Yeah. So you can see my screen. Okay. So this is, okay, let me show you from the beginning. Let me close everything here and close. And what else? Okay, let me also close this. So I close everything now, okay? So when you install the software, you will get this type of desktop icon called the GNSS analysis. So you double click. Okay. And one thing you have to remember is to use this, you have to have an internet connection because it will download some navigation data which is necessary. And from time to time, it will connect the MATLAB server to check the update version and so on. So probably you need the internet connection. But if you already need it, but you have to provide it manually in that case. So when you run this software, background is it's loading all your MATLAB runtime libraries. Okay? And if you're not sure whether it's working or just hang, you just press Ctrl-Alt-Delete and you can run your task manager. Okay? So you can see your CPU, you see it's working. Okay? So let's wait a few minutes. Okay, it takes some time. Now you see something is coming. Okay. Now, so we have something coming up here. So this is my menu. Okay. So now we have the screen. Okay. So you can see my screen. This is the software. And now you press this button, Find Log File. Okay. This is to select your input data file. Oh. Okay. So I will select my data file. Where is it? Okay. Okay, let me select this file. So you see, you have only one. Okay, let me do one thing. Wait. Let me select the file. Let me show you the data itself, how it looks like. I need to select a good data. Let me see. Oh, I don't know where is this. Okay, so this data I logged in Melbourne when we went for MZA near the RMIT campus in a park. Okay, you see, I was here and I put my Android device here in the park on a bench. So probably you can see where am I. Oh, where is it? Let's see the bench here. Yeah. You see? So I put the mobile on this bench here, and I was sitting here. So maybe I might be blocking some satellite or maybe some small reflection from my body. Anyway, the mobile phone was here on the bench, and I was sitting here. And this mobile phone has L1 and L5 capability, dual frequency. And you can see these tall trees around, okay, but not so many leaves. But here you see, a bit far away, but there's one big tree here. So we see the trees around here, okay. So this is where the data were logged, okay. Let's see how it looks like. It's already the output, but I just wanted to show you how the raw data looks like. So when you log the data in the mobile phone, you don't have so many files. I delete all these files, which were the output. Okay. Okay. So this is mobile phone. Okay. Only this file. And if you open this file, okay, the data like this. So actually, when I log, so I log many things. NMA data. You can see NMA outputs. You can see the raw data. These are the raw data. Okay. The receiver is logging. So these are the raw data. And you can see probably nav data somewhere. I don't know, where are these navigation data? Okay, there must be somewhere, or I did not select the option. Anyway, so this is the raw data that your mobile phone outputs. Okay, so this is how it looks like. It's not a binary, it's ASCII file, but it's look like this. So from here, we don't know what to do is, so you copy this to your folder first in your computer, and you select find log file. Now you select this one, you open the file, and it says log file found. Now click analyze and plot. Okay. Yeah. So then you press this button, analyze and plot. Okay. Now it's analyzing. It says analyzing log file. Okay. Now you look here, you got one more file. You see raw.csv. Okay. So you got raw.csv file, and then it says, then click analyze button again. The reason why it's saying is that because this is a zip file. Okay, this file is zip file, and I didn't put my unzip software in the path, so the system cannot find this unzip software automatically. So I am going to do it manually. So I will just unzip. Okay, I will unzip, extract here. So I'm unzipping. This is the navigation file, which is downloaded. Okay, it downloaded from the IGS site. You see, it accessed the IGS site. Yeah, you can see the message what file it downloaded. Okay, so it downloaded the necessary navigation Runx file from the server somewhere. Okay. And now I have to press analyze again. So I press again. Now it's checking whether all the necessary files are there, because this end file is for GPS. Okay. And also this G is for GLONASS, so I need to unzip again. So okay, I unzip. Now I have two navigation files for GPS and GLONASS, and also the raw data logged by the receiver. Now if you file, so it looks like this. All the headers here elapsed. All this is very, very detailed raw data. And to understand full bias nanos and all, so you really need to check the manual and need to understand how the GPS signal processing takes place. Some books, or we can do separate webinars just to understand all these small things. That's very deep GPS signal processing inside the receiver. Okay, and here are all the CN0 values. You see CN0 not like in the integer. Now it's very, very detailed CN0. And for some research, these detailed CN0 are very, very important. And pseudo range difference, okay, these are not the pseudo range itself, but they are related with the pseudo range. And these are something like the pseudo range, rate of change of pseudo range every meter, how the pseudo ranges are changing. And then your carrier phase accumulated data range, this gives you all the carrier phase information and how they are changing and what is your carrier frequency and all. So this is very detailed data. And from this data, we now compute the pseudo range. Okay. I will do analyze and plot once again, and this will take some time. Okay. So I press the button. Now it's processing. Now you check here, you will be getting more files as it outputs. Okay. And also you are getting some displays, some message here. Okay. Now it will take few minutes, maybe about 5 minutes. Quite long time. Maybe sometimes 15 minutes, depending upon your computer. So please wait about 5 minutes. And you see it's now producing many types. These are the RANX navigation data for Compass, Galileo, and QGSS. So we see this, you see the CPU, it's working, it's not the computer hang. Okay, now we see some plots here coming up. Okay, so we can see, okay, we are not moving. We can see the points all scatter. So we don't do any correction on this data. It's just a standard processing, SPS, standard positioning service. So we don't do any correction. So the different types of correction after this. We can do DGPS, we can do RTK, we can do PPP, and so on. And we can see how the accuracy will look like by the data log by the Android phone. And still we have to get few more plots. So you will see 9 plots, 9 different types of plots here. So now we have only 5. Okay. Okay. So this is all. Okay. Now we got all the output from our data. It took some time. So you see the CN0, the bar for some of the best ones here. And this is CN0 for all the visible satellites. And it's quite a lot, actually. Maybe you can see around 40 satellites here. Or here, the sky plot, okay? I mean, 40 different types of signal, 40. But we have L1 and L5, and for GPS, QGSS, Galileo, GLONASS, and Beidou, 5 satellite systems, and L1 and L2. And the clock bias and the frequency drift means that every receiver, they have a clock, internal clock. And when they need to check the GPS signal, so it first generates the replica signal inside the receiver itself. And that replica is generated based on the timing, the clock timing it has inside the receiver. And if that clock drifts a lot with respect to time and temperature, then we can see how the clock is drifting here. So these type of graphs will tell you how good is your receiver inside a device. Okay. So if it has a very big, like fluctuations, that means whatever you do, your accuracy or the measurement will have a low accuracy. So these are very good, some reference things, accuracy level of the receiver. And these are the output things. So this is the scatter plot of the X, because it displayed by default like this. So the screens, it's very small and difficult to see. But when you process yourself, you can look at these, each of these figures. You can make it large and zoom it and all, or you can just print out and see the figures, or you can just select or deselect the satellites that you want to see separately. Okay. The raw pseudo range error, okay, the error in the pseudo range itself. So if you have error in the pseudo range, definitely you will also have the position error. So because your position is computed by using the pseudo range data. So these are the plots you get after processing. Menu. Here we have all this now, everything is done. So it says, it gives you the message and says elapsed processing time for this file is 3.2 minutes. And also it created many other files like the KML file. And after everything is done, you see it has selected all the available visible satellites, and you can create a report of these outputs. So press make report. And now it will create the data for your report automatically and create a HTML file. Okay, so this is the report file. So this is automatically created Android GNSS analysis. So some table of contents, test summary. Okay, so your input file and log file, your GNSS logger, and what model, what phone you are using, and everything is given here. And some outputs, we don't have it because we don't have the AGC data. So it doesn't output some of those things that it tried to output. Receive signal strength. So zip, and it explains a little bit about what are these figures about. For example, the mean value of the 4 strongest median of a median value of the strongest signal is 34.3. Pass fail reference is 38. So I don't know what do they mean by this. need to check the user manual. So L1 signal compared to reference GPS. Okay, I need to check all the meaning of these in details. I myself is very new to this analysis, because this device was available to we just got it about I think just a month ago. So we are just logging some sample data and doing very some tests, but it's not done at too much. It's very little work on this at the moment. So we'll be doing probably next year, not in December. From next year, we'll be working on this. Then we'll have a lot of things to talk. But anyway, so there and data processing tools are there, and they are very nice. They don't generate errors, no such problems. At least I didn't encounter anything. It worked very smoothly, and we can have a very nice data. And also all the source files are available. And if you want to modify these MATLAB files, so you can do yourself. And also we have another MATLAB version of the source file in the GitHub, which is different from this one. But for that, you need to have your own MATLAB license. It's cheap. It costs maybe $100 for the basic license and another $30 for every tools you need it. But for the commercial, it's about quite expensive. So you have to pay maybe around a few $1,000s. That's quite expensive. So anyway, so this one shall be more than enough to learn in the beginning. And if you are really interested to do it, or if you are a programmer, then you can use manipulate your raw data. For example, what I do in my smartphone is I read the navigation. I read as I like it, and then I also even read more other information which is not available in this one. So we can have even more such raw data than it is available now. And I do it for my own signal authentication, jamming, and all these analysis. So that's possible to do it. So that means by using this type of tool and raw data logging, so it has opened a completely new window or new door to do more such type of research, as well as new system development, which were not possible before. Okay. So this is a very detailed report. Okay, not so detailed, but the figures you saw in the desktop, so it put everything nicely in one single HTML file and explains a little bit on this. But it's not so nicely formatted because you see the text size and all, but this can be edited or modified without any problem. So these are the things that I would like to let you know today: how to log the data, how to process the data, and what are the software to do this, so input and output processing and all. All from my side. And what else I have? That's all. Okay, let me check if anything else. And to log the okay, I need to show you some of other tools. So let me just type here. So these are some of the GNSS logger, and also we have a GeoPlapla Rhinex logger, and what else? There's one more. And GNSS compare. Okay. So these are the 3 apps that you can use to log raw data. So GNSS Logger you have to download from the homepage. It's not in the Play Store. And these two, I think you can download from the Play Store. So this one, it outputs Rhinex data, Rhinex OBS file. Okay. So this one will be this will be much easier for you. All these raw data processing, because if you have this app, so you can just put in your Android and press log the data using this, and the output file is your Rhinex OBS file, and you already know how to process the OBS file. Okay, you have all the necessary information, and this supports L1 and L5 double frequency, and this is to compare position accuracy from L1, from GPS L1, GPS L, Galileo E1, and Galileo E5A. L1 alone. Okay. GPS L1 versus GPS L5 versus Galileo E1, Galileo E5. Oh, I think this is L2. I need to check, not L5. Anyway, so you can try yourself. Just install this app and run it, and then you can see how the position data looks like from each of those signals. So GPS and Galileo combined, you can separate all these, and you can see the output from each of those systems, and that's very interesting how the errors they differ. Okay, so this is all from my side, and if you have some questions, so please let me know. Either you can send it in chat, and you can ask, right? You can ask now. You can unmute your mic, and we can talk if you have. And I will stop here. I will stop sharing this screen. Okay, is there any questions? Because almost all of you, your microphone is off, it's muted, so okay. So whether we can get the carrier phase data. Yes, I need to check what we are getting it. So the one we are getting is the carrier frequency. So I'm not sure whether we can get the carrier phase. I need to check it. Okay, it seems that okay, so one request from my side is that if you have an Android device, so please install the app, GNSS Logger app, And please check whether your device can output the raw data or not. If your device can output raw data, please send me the information, which device you use, and if possible, just send me a small sample of the raw data so that I can see what type of raw data are available, and also what type of receiver, I mean signal, GPS only or GPS Galileo GLONASS. So we can update the list in the in this library, and we can share the information. And also in Europe, so there is a working group on this, and I'm one of the members. So we'll be getting more information on this, and as we get more information, so I will keep on posting in the webinar, not webinar, in my homepage, and I will send you the information so that you. So maybe we can have maybe another webinar after 1 or 2 months. Yeah, in Europe is that Galileo, I don't remember. I think that this Galileo, yes, GSA, they have a raw data measurement, something called the working group or something like that. I need to check the exact name. Okay, so if no more questions, so I would like to stop here and thank you very much. And we hope to see you in our next webinar. It will be held sometime in January, maybe mid of January or third week of January. So please attend the next seminar, next webinar, but the topic is not decided yet. Probably we'll have one webinar on the early warning system or emergency message or something similar. And also, if you want to learn on some specific topics, so please let us know. We'll try to organize it. Or if you want to do yourself, so you are also most welcome to do it. Okay, so I stop here and thank you very much.